Kia ora Year 12 and Year 11. I decided I'd better make you guys some videos as well, so you don't feel left out. So here is one, especially for Lucas Bunny, about logs and exponentials, and I've called it cockroaches in the laundry. I hope you like the pictures. So there are 14 cockroaches on my laundry floor today, and they're increasing at a daily rate of 17%. Okay, so forget about any real life dramas with that rate. We want to figure out two things. The first thing is super easy. How many will there be in a week? And then we want to work out when there will be 1,000 cockroaches, ignoring problems with whether they'll fit into the laundry. So the first thing we need to do here is to write an equation, and the equation is going to be an exponential equation. So it's going to go like this. We'll call C, let C be the number of cockroaches, and it's going to be the initial number, 14, and we know they're growing at a rate of 17% per day. So we're going to make this rate will be 1 plus the 17% to the power of t. So we've done lots of these in class, so that's why I'm skipping through where all of that came from. But basically my growth rate is 17%, and today is t equals 0. So to figure out how many there will be in a week, we just have to substitute in t equals 7, because it's a daily rate of 17%. So that will give me c is equal to 14 times 1.17 to the power of 7, and that works out to be, right, sorry about that, I hadn't worked that out and I didn't have a calculator. That works out to be 42 cockroaches. Okay, so when will there be 1,000 cockroaches? What we have to do for this is we have to solve 1,000 is equal to 14 times 1.17t. So dividing through both sides, first of all, I'm going to get 71.42 ... so hold that in your calculator. Right, so I've taken that 14 and I've divided both sides by 14. So 71.42 is equal to 1.17 to the power of t. Now I'm going to take logs of both sides because I'm trying to figure out t, which is up in the power. So we've got the log of 71.42 is equal to the log of this. Now I'm doing all of the steps here. I'm applying my log rules now. Remember that the log of a to the power of b is equal to b times the log of a. So here, this right-hand side works out to be t log of 1.17. So the last thing we've got to do to isolate t is to divide both sides through by this. So we get the log of 71.42 divided by the log of 1.17 is equal to t. So that gives me t is equal to 27.18. Now, after 27 days, there won't quite be 1,000 cockroaches. So our answer should be after 28 days, there will be 1,000 disgusting cockroaches. But before we finish, I want to just show you again what the graph of that situation looks like. So exponential graphs with a growth rate of, say, 17% grow so quickly that I've had to do it in 2 videos. So this equation is my cockroach equation, 14 times 1.17 to the power of t. So remember that we're going to go, that graph is going to go through 14, so 14 will be my y-intercept, and you can see on there my 7-day value coming through just at the top of the graph here at 42. But to see what's going on, when do we get to 1,000, I've had to shrink the graph like this, so I've changed the scale. So it's the same thing, but just here I've stretched this out. And you can see massively fast growth, and on day 27 you can see us reaching the 1,000 cockroach mark. All right, thanks for watching. Theta exercise 1904 has got lots of questions like this at this level and then some harder ones. So these kinds of questions are well worth doing. They come up every year in the exam, but more importantly, they're actually really, really useful for real life. So maybe not the cockroach one, but every time you're dealing with investments, money in the bank, saving, buying a new car, and all of that kind of thing, they come down to this basic pattern of an exponential. So go do some extra ones now.